Hello, this is classwork 1, part 2 from week 9. We're going to do rational zero theorem. The rational zero theorem helps us narrow down the possible rational zeros using the ratio of factors of the constant term. The constant term is the AO term, which is the last term here, and the factors of the leading coefficient term of the polynomial. The leading coefficient term is the one in front. So basically, if the polynomial is in order from the highest degree down, you have the factors of the last term, which is the constant term, divided by the factors of the leading coefficient term. This will help us find the number of possible rational zeros. Rational numbers are numbers that can be written like a fraction, like an integer or a fraction, not irrational and not imaginary. Irrationals are square roots, and imaginaries have eyes. So let's go ahead and find the factors of 6. That will be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Factors of things that multiply to get 6, such as 2 times 3 or 1 times 6. Don't forget we can have a plus or a minus, so we can get positives and negatives as well. So those are the factors of the last term. Let's find the factors of the first term, which is 3. So the only thing that multiplies to get 3 are 1 and 3, so those are the only factors, plus or minus 1 and plus or minus 3. So the rational zero theorem states that we need to find the factors of the constant term on top, which is the last term, factors of 6, divided by the factors of 3. So this is the tricky part. We're going to take the 1, and we're going to divide it by 1. So plus or minus 1 divided by 1 is 1. Then we're going to take it, and then we're going to do divide by the 3. So we'll take the first one divided by 1 and the first one and divide by 3. So we get plus or minus 1 for the first one, and then when we divide by 3, we get plus or minus 1/3. Next, we're going to take the next term, which is 2, and divide the 2 by 1, and then divide the 2 by 3. So we get plus or minus 2, and then we get plus or minus 3. Now we're going to take the third term. So we've already done the first, we've already done the second. Now let's do the third term divided by 1, which is 3, plus or minus 3, and then we'll divide it by 3. 3 divided by 3. That will simplify to 1, so that's going to be a duplicate. We'll talk about duplicates in a minute. And then the last thing, we have to take the last term, 6, divide that by 1, and that will give you plus or minus 6. And then we divide 6 by 3. 6 divided by 3 is 2, so we're going to get another duplicate in a minute. So let's list all of them. 1, 2, 3, 4, 5, 6, 7, 8. And then since they're plus or minus, that's a total of 16. But since we're going to get rid of some of the duplicates. So duplicates. So for instance, plus or minus 1 and plus or minus 3 over 3, that's also one. We can get rid of that one. Plus or minus 2 is the same thing as plus or minus 6 over 3, so we can get rid of that one. So instead of having 1, 2, 3, 4, 5, 6, 7, 8, and then all the minuses, which is 16, we actually have 1, 2, 3, 4, 5, 6, and then all the minuses will give you 12. So there's 1, 2, 3, 4, 5, 6 positives, and then with all the negatives gives you 12 choices. You take all those 12 choices. Those are the possible rational roots. Now, because this is a cubic, we can have up to 3. So let's go ahead and get rid of this little pen thing here. Remember that if a is a root of a polynomial, then if you plug that root into the polynomial, you'll get 0. So let's check each number. We'll take the 1/3, we'll take the negative 1/3, we'll plug in each number until we find which, up to 3, which 3 will be the actual roots. So if we plug in 1/3, which means if we take 3 and then do times 1/3 cubed, minus 4 times 1/3 squared, minus 17 times 1/3 plus 6, if we plug that into our calculator, we'll get 0, which means yes, it's a root. If we plug in negative 1/3, we get 100 over 9, which is a no. If we get, so 1/3 did work. You can also use a calculator, or Desmos has a calculator you can do. You can type in the equation, type in f of 1/3, as long as you put f of x, and then you'll get some answers, and that will be a little bit quicker, so you don't have to type in the equation over and over again. So I do like to use the Desmos calculator there. Anyways, if you plug in -1/3, that's a no. If you plug in 2/3, you do not get 0. You get -56/9. That's a no. If you plug in -2/3, that's a no. If you plug in 1, that's also a no. If you plug in -1, you get 16, so that's a no. You're trying to get 0. You plug in 2, you get -20, that's a no. You plug in -20, you get 0, and that's a yes. So -2 worked. You plug in 3, that's also a 0, and that one worked. And that's as most as you can have anyway. Since it's a cubic, you can only have up to 3. And then these are no. You can also have some imaginaries, and that's why you can have up to 3, but no more than 3. And again, here is using the Desmos calculator. If you go to desmos.com, you can plug in those, and it will help make it go a little bit faster if you choose to use that calculator. And then when you look at it, you'll get 1/3 as the actual rational zero, which means it will cross the x-axis at 1/3. It will cross at -2. It will cross at 3. Desmos also has a graphing ability, so you can see where it crosses as well. Okay, so now for the actual classwork part 2. State the possible rational zeros for each function, then find all the rational zeros. So we have to do the factors of 2. Okay. And we also have to find the factors of the first number, the first coefficient, which is a 1. So we have to find the factors of 1. Okay, the only thing that multiplies to get 2 is 1 and 2, so you have plus or minus 1 and plus or minus 2. The factors of 1 are just plus or minus 1. So when you divide plus or minus 1 and plus or minus 2, when you divide it by plus or minus 1, it doesn't matter. You just get 1 plus or minus 1 when you divide by 1, and then when you divide by 2, you just get plus or minus 2. So your possible rational roots, or zeros, possible rational zeros, are 4 choices: plus 1 or minus 1, plus 2 or minus 2. So those are the only 4 choices. So I'm going to show you how to plug those in. So if you take a calculator and plug in 1, it won't give you the right answer. It would actually give you 12. So what I mean by plugging in 1 is 1 into the equation. X cubed, so 1 cubed, plus 4x squared, so 4 times 1 squared. So your x is 1. 5 times 1 plus 2, that gives you 12, so that's a no. Then when you plug in -1 cubed and you plug that into the calculator, it gives you 0, so that's a yes. So -1 worked. And then 2 did not work, it gave you 36. And when you plug in -2, it did work, it gave you 0. And that was a yes. So these are the actual zeros. 2. If you want, you can graph it, and you can find that there is going to be a multiplicity. And I'll explain that in just a second. So out of the 4, the only 2 that worked are -1 and -2 are the rational zeros. So if you want to find out if there's a multiplicity, which means if one of the roots is twice, we can go and graph it and see if it bounces. So we can do that right now. X cubed plus 4x squared plus 5x plus 2. Let's go ahead and graph that into Desmos. So let's take a look. So let's get rid of those other ones that we did earlier. And if we plug in, let's do f of x instead of y. F of x equals x to the 3rd plus 4x squared plus 5x plus 2. And if we zoom in, it crosses at -2 once, goes straight through, but at -1 it does a bounce. So that means if this was factored, since x equals -2 is a single, root, and x equals -1 is a double. If this was a true factor, it would be x plus 2 times x plus 1 squared, because this one is a bounce, if you want to write it in factored form. But they're just going to ask you what the actual roots are. So we have a single and we have a double here. So let's take a look at our answer key here. And if you notice, you'll see the -1 multiplicity of 2. So -1 worked and -2 worked. So you can go ahead and try to do the rest of them, number 2 and number 3 and number 4. Just remember you need to find the factors of the last term divided by factors of the first term. So factors of 1 and 5. So 5 would be 1 and 5. And the factors of 5 are also 1 and 5. And when you start dividing, 1 divided by 1 is 1. 1 divided by 5 is 1/5. 5 divided by 1 is 5. 5 divided by 5 is 1. So you have these 6 choices, because since you have 3, you actually have 6, because there's plus and minus of each. Test each one. See which one either gives you 0 when you plug it in, or see which one crosses the x-axis. And it looks like it can cross up to 3 times, and 3 work. The 1/5 works, the -5 works, and the -1 works. Go ahead and test it on your own and check your answers. Don't forget to show all your work. Don't just post your answers. Your work should look something like this. And if you have more questions, come to the tutorial if you're not getting the answers right. Have a great day.